Okay, applications of integration. Okay, the first thing it says here is always draw a sketch, because you've always got to be careful if you're evaluating an area, you've got to be looking out for those little negative areas. Also, the sketch can help you find intercepts if it involves two graphs. It's just great to always have a sketch. So our first one, we want to sketch y equals cos of half x, and then, so that's between 0 and 4 pi, marking both intercepts, and then we're going to find some areas in part B. So first of all, our sketch. To sketch it, I would like to know the amplitude and the period of this graph. What's the amplitude? Have I changed it from normal? How do you change the amplitude of a sine or a cos graph? Or a tan graph, really. You put a number in front of it here. So I haven't changed it. So what is the amplitude normally? Because it's the same thing. 1, thank you. So the amplitude is still 1. I want to find the period. For cos and sine, the period of the graph is usually 2 pi. Now, if I change it, we change it by putting a number in front of the x, which has happened in this question. So you divide by that number. So I'm dividing by a half. 2 pi divided by a half is 4 pi. So no surprise really that they want me to sketch between 0 and 4 pi, because that is one complete revolution of the graph. Okay, so let's draw pi, 2 pi, 3 pi, 4 pi. The amplitude is 1 and minus 1. This is the cos graph. So the cos graph starts at 1. It will come down to 0 at the pi, down to -1, up, and back where it started by the time I get to 4 pi. All right, there is my graph. Question B, as you're still drawing that, I'm just going to read it down here. Question B says to find the area between the curve and the x-axis. Now, the area will be this little part in here, this big bit underneath, and then another little bit down the end. If I was to integrate that right now from 0 to 4 pi, what would I get? 0, but that is not the area. Okay, the integral would correctly be 0, but if I'm asked to find the area, I need to take into consideration that some of that is negative and some of that is positive. Okay, so we are going to divide this into 3 sections. Technically, I could probably do it in 2, because that one is going to be the same as that one, but whether you identify that or not might be interesting, may or may not do that. Would you do that? Would you see they're the same? Oh, so can we just do 2 then? All right, let's do 2. All right. So let's do area 1 then is going to be these 2 parts combined. The 2 positive parts combined. So area 1. To integrate, all I'm going to do is, I'll say area equals, I'm going to integrate this first one between 0 and pi and times it by 2. I'm just going to double it because that one's the same size. Okay? So 2 lots of, I'm integrating between 0 and pi, and my equation is cos of half x dx. All right, here comes the integrating trig part. To integrate the cos of half x, I need the derivative of the function out the front. Do I have that? No. Now, as an alternative, if you don't want to do the whole fiddle part, if you don't have the derivative at the front, when you differentiate, the numbers multiply at the front. So if you're integrating, the function divides to the bottom. That's your alternative, but it's just not on your formula sheet. Does that make sense? No? Well, let me show you. So the 2 out the front stays there. The cos of half x, oh sorry, don't write that, because I've got to integrate it. Cos integrates into sine, so I go sine of half x, but then I divide by the half down the bottom here. That's your other option rather than trying to get the derivative out the front first. Okay, it's effectively doing the same thing. That's between 0 and pi. You can do it the other way if you like the other way better. I'm just showing an alternative. Okay, so the half on the bottom would times up to be a 2 on the top. With the 2 that's already there, it would become a 4 sine of half x. Let's change that between 0 and pi. And now let's sub in. So it'd be 4 sine of pi over 2 minus 4 sine of 0 equals, sine of 0 is 0, so that's nothing. What's sine of pi over 2? 1, so the answer is 4. Okay, there's my positive area. Let's do area 2 being this negative part down here. You might already know what that's going to be, but we're doing it separately because it's negative. So area 2, the area is going to be equal to the integral from pi to 3 pi of cos of half x dx. Now, we've already integrated this, so it's going to be the same thing. It was cos of, I keep writing that, sorry. Cos integrates to sine of half x over a half. But the half on the bottom could just times out the front to be a 2. So it is going to be 2 sine half x. Sub in your values, and you'll get 2 sine 3 pi on 2 minus 2 sine pi on 2. And are we got an answer? Or do we already know what it is? Not just 4. It should come out as minus 4. It's negative because it's below. Okay? But that means my total area is 8. Because it's 4 above and 4 below, we take the minus sign off it to say that it's 8 units squared. That's why I can't just put these two integrals together, because if I did, I would just get 0. But I can see that the two areas will make an area of 8. All right, next one, question 2. Show that the curves y equals sine x and y equals sine 2x intersect at x equals pi over 3. So, I just realized I did this question using something only the extension people will know. Is there an alternative? I have to do it by substitution. I was just looking at my thing and I did the sine extension people. I broke that out into 2 sine x cos x, which I shouldn't do because these guys don't know that. And then I solved the equation. Okay, so I'll have to do it by substitution then. So by substitution, I will just sub in into, so this is going to be equation 1 and this can be equation 2. I'm going to sub the pi over 3 into both of them. So into 1 first of all. So that will give me y equals sine of pi over 3. Okay, what does sine of pi over 3 equal? Root 3 over 2. All right, now we're going to show the other one gives us the same thing. So we sub pi over 3 into equation 2, and we will get y equals sine of 2 pi over 3. Hopefully you get the same thing, do you? Excellent. Okay, so we've shown that we sub pi over 3 into both of them, and we get root 3 over 2 for both of them, which means they are both at that exact same point. Okay, so now I want to sketch the curves in the interval between 0 and pi. All right, let's start with y equals sine x. That's the easier one. Y equals sine x. I'm only going to pi, so I'm going to put pi at the end and then divide this up. So that will be pi on 2, and this will be pi over 4. 3 pi over 4. Okay, so if I'm doing sine x normally has a period of 2 pi. If I'm only sketching between 0 and pi though, I'm only sketching half of a revolution, an oscillation. So it's only going to, at the halfway point, it'll be at the top, it's going to go up and down to pi. All right, that is the y equals sine x graph between 0 and pi. For y equals sine 2x, my amplitude hasn't changed, but the 2 is changing the period. The period is going to be 2 pi over 2, which is pi. Okay, so this one's going to do a complete rotation by pi. So it's going to start at 0, end at 0. In the middle, it's going to go through pi over 2. And then at pi over 4, it's going to be at 1. And 3 pi over 4, it'll be down at negative 1. So it looks like that. That is y equals sine of 2x. Now, we found already, and let's mark it on here, this point of intersection was from part A. That value there, or maybe I can put it down here, this is pi over 3. Put it in both places just to really emphasize it. X equals pi over 3, right there. Okay, sketch it. We've done that. Part C says, find the area contained between the curves, between the 0 and pi over 3, which is this little part in here. I want to find that area. When you are finding the area between curves, you want to integrate the top one minus the lower one. So it will be area equals, I'm integrating from 0 to pi on 3. The curve that is on top is the sine 2x. And then I minus the one that's on the bottom, which is the sine of x. And don't forget the dot dx. All right, integrating each of those. I'm going to use my little shortcut for that sine 2x. Integrating sine goes to cos, but is it positive or negative? Negative. So it's going to be negative cos 2x over 2. Putting the derivative of my function on the bottom. Okay, then the second one, it's a negative sign at the moment. So when I integrate sine to be a negative cos, that will become a plus cos of x between 0 and pi over 3. All right, and now we start subbing things in. We go minus cos of 2 pi over 3 all over 2 plus cos of pi over 3, and then minus, sub the 0 in, minus cos of 0 over 2 plus cos of 0. Okay, I put lots of brackets in there to make sure that I didn't make a mistake with any minus signs, like here, for example. Please be careful. Frequently have people making very small little calculation errors, which we'd like to minimize. They're very frustrating, I know, for you guys when you know how to do something and then you accidentally calculate. I'm not looking at you, child. No, I'm looking over here. All right, type it in. What do we get? You're not the only one. It's for everybody. Everybody does. Lots of people do it. Did we get an answer? Trying. It's a long one. Yes, it is a quarter. Units squared, because it's an area. All right, question 3, last one of the booklet. Show that in the interval between 0 and 2 pi, the curves y equals sine x and y equals cos x intersect at pi over 4 and 5 pi over 4. This time I can actually do it algebraically. Woohoo! Okay, sorry, that's exciting. I don't like this guessing methods, subbing stuff in. I like algebraic stuff. Okay, so if I want to solve these equations simultaneously, they are both y equals. So it would simply be that sine x is equal to cos x. Yes? Is that all right? Because it was y equals sine x and y equals cos x, so that means that sine x equals cos x. Yeah, you're subbing one into the other effectively, sub one into two. Okay, now we don't want to have an equation that has sine and cos in it. So we're going to turn it into tan by dividing everything through by cos. Sine divided by cos is tan, and cos divided by cos is 1. All right, so now I have a much nicer equation. Tan x equals 1. Tan is positive in the first quadrant and the third quadrant. And I want to know tan of what gives 1. So you can type in your calculator inverse tan of 1, or you might know it from exact value triangles. It is 45. 45 in here, 45 in there. So I have to do both solutions. There are two quadrants. So the first one is 45, and I've done it in degrees. I'll do it in degrees here. 45, and the other one is 180 plus the 45, which is 225. Now, I've done it in degrees. My answer needs to be in radians. So we convert our degrees into radians by putting 45 over 180 and put the pi in. So it's 45 pi over 180, and that will simplify down to be pi over 4. And then you do 225 pi over 180, and no surprise, you get 5 pi over 4. So there are the two solutions that we were meant to get. Question B. Sketch the curves in this interval and find the area contained between them. I'm just going to sketch the two curves. I don't want to try and cut it off too short. That makes it more complicated. So my two curves was y equals sine x and y equals cos x. So 1, 2, 3, 4. Javan, do you guys need to sit apart? All right, you shouldn't be talking the whole way through. That's actually rude. So can you sit quietly, please? Drawing. Sine, we got 1 and negative 1. Then I'm going to start with sine x. Sine starts at 0, goes up to 1, down to 0, down to negative 1, back up to 0. That is a little bit wonky, but there is my sine graph. Now my cos graph is going to start at 1, go down to 0 at pi on 2, then down to negative 1, back up to 0, and all the way back up to 1. Neither of these graphs have had a change in period or amplitude. They are very basic sine and cos graph. Okay, so we found in part A that the point of intersection, this one here, would be at x equals pi over 4. This one down here, this point, would be at x equals 5 pi over 4. Because now I want to find the area between those two curves, this lovely part in here, which of course is going to be like the last one where I do the top curve minus the lower curve. So area equals, I'm integrating from pi over 4 to 5 pi over 4. The curve that is on top is sine. Sine's on top. Sine x, and then minus the cos x that's underneath, dot dx. All right, how do we integrate sine x? What does it become? It becomes negative cos x. Good. What does cos x become? Sine x. So the minus sign that was already there will stay there. Sine x. Between pi on 4 and 5 pi on 4. All right, and sub in so we can put it in our calculators. Minus cos of 5 pi on 4 minus sine of 5 pi on 4. Then we minus sub in minus cos of pi on 4 minus sine of pi on 4. Careful with all those many minus signs. I got 2 root 2. Oh, I still wanted you guys to do it. You don't just quit because I tell you the answer. Still good practice. I was just giving you the answer to check to make sure you got it right once you typed it in.